Welcome back. This lesson is lesson 29. It's about polar coordinates r and theta and how to convert from polar coordinates to rectangular coordinates and how to interpret polar equations. So let's go to do problems, and we start with the basics ideas of polar coordinates. Polar coordinates are let me okay, polar coordinates. So when you have polar coordinates, you have a set of points. This is the set of points in the Cartesian coordinates, is the x and the y. So this point x and y, it says how much meters you have walked in the x direction. Let's say 3. So the x is 3. And how much meter you have walked in the y direction. So this is the y direction. Let's say 4. 4. Okay, so the y is 4. So the x and the y locate unequivocally. What is the point? There is no way that you can be confused. You walk 3 meters to the x-axis. Later on you walk 4 meters, 1, 2, 3, and 4, and you are at the point. No way to have any uncertainty where is the point. So the point is 3, 4. In polar coordinates, the instructions say, tell me how far you are. How far you are is 5, because Pythagoras theorem say that 3 squared plus 4 squared square root is 5. So tell me how far you are and tell me which angle you are. So I will tell you the 5 and I will tell you this theta. So in polar coordinates, the data is not the x and the y. The data is the r and the theta. For this example, the r is 5. And the theta can be obtained by watching the picture and looking that tangent theta is 4 divided by 3. So theta is arc tangent of 1/3. So whatever it is, the angle, whatever is the angle, 30 degrees, or pi divided by 6, whatever. So theta, you will put it. Let's say that this is pi divided by 6. I don't want to take the calculator. It's not pi divided by 6 for sure. But let's say whatever, pi divided by 6. So we have converted 3, 4 into a polar coordinates. So this is the r and this is the theta. Well, this is the x and this is the y. The point is exactly the same point. So we take the following standard rule, if we can say. Theta is positive if you walk counterclockwise. R is positive if you go from the center, for example, this point is the point in polar coordinates is the point 3, 0. The r is 3 and the theta is 0. Oh, in Cartesian coordinate, this point, the x is 3 and the y is 0. Wow! It looks the same point, but it's not the same point. Well, it is the same point, but even if they have the same coordinate, you have to be sure that you put the x and the y. For example, this point, if you rotate here to the 5, this point is in Cartesian coordinates. The x and the y is the 0 and the 5. But in polar coordinates, the r and the theta, what would be? Will be 5 for the r and pi pi divided by 2 for the theta. So this point is under the angle pi divided by 2. So the instruction is go 5 meters out of the center and rotate, go 5 meters out of the center in the x direction. And now later on, rotate pi divided by 2. Oh, and this is the r and this is the theta. So this point in polar coordinate is the same point in Cartesian coordinate as the point 0, 5. Okay, let's go to do problems and we practice this idea. Okay, let's go to do problem 1 that say convert the point r equals 8 theta pi divided by 2 to rectangular coordinates. What is this point? This point is the point, let's go, is the point where r is 8, so walk in the x direction 8 meters. 8. And rotate this r, rotate pi divided by 2. So you are here. You rotate pi divided by 2, so you have a semicircle of radius 8, and the angle is pi divided by 2, so it's this point. Who is this point? This point is the point 0, 8 in Cartesian coordinates. So the point 8, pi divided by 2, r theta, is converted into the point x, y, 0, 8. So let's go to do it formally. The x is the r cosine of theta. The y is the r sine of theta. Why? Because this is the point x and y, this is theta, and this is r, and it's clear from the picture, from the figure, it's clear that r squared is x squared plus y squared, and it's clear that r cosine of theta is the x. Why? Because cosine of theta is x divided by r. And it's clear from the picture, that r sine of theta is the y. Why? Because sine of theta is y divided by r. Sine of theta is y divided by r. So these are the equations. Let's go to put it. So the x will be the r, so I'm using this equation, the 8 cosine of pi divided by 2. What is cosine of pi divided by 2 is 0. So 8 by 0 is 0. And the y is 8 sine of pi divided by 2. So the 8 is 8 by 1. 8 by 1 is 8. So the point in Cartesian coordinates is the point 0, 8. So I have convert the point 8, pi divided by 2 into the point x, y, 0, 8, that is the same point that this point in polar coordinates. It's the same point, only the information r and theta is different than the information x and y. Let's go to do another problem. Let's go to do this problem. Convert the point r theta equal -2, 5 pi divided by 3 to rectangular coordinates. What is the x? What is the y? Well, the x is r cosine of theta. The y is r sine of theta. So if you plug in numbers, you will find the x equal -1 and the y equal square root of 3. So the point is the x is -1 and the y is square root of 3, so should be a point on this quadrant. Okay, but how you will do it visually, this is how I will do it visually. This is the point in polar coordinates r theta, This is the point 2, comma 0. The theta is 0, the r is 2. When you rotate, you go to this point, and this point is the point 2, comma pi divided by 2. The r is 2, the theta is pi divided by 2. When you keep rotating, you arrive to the point, the r is 2, and the theta is pi. If you keep rotating, you arrive to this point. This is the point, the r is 2, and the theta is 3 pi divided by 2. 3 times pi divided by 2. So, when you rotate 3 pi divided by 2 plus pi divided by 6, you arrive to the point, the r to this point, that is the point 2, comma 5 pi divided by 3, in a way that this angle is 5 pi divided by 3. But this is not the point. Who is the point minus 2, comma 5 pi divided by 3? The point 2, comma 5 pi divided by 3 is this point. What is the point minus 2? Is the point that is the image through the center of this point. So is here. So this is the point 5 pi divided by 3. This is the point in polar coordinates minus 2, comma 5 pi divided by 3. And the x of this point is negative. Oh, you see, minus 1. And the y is positive, square root of 3. So this is the problem. Let's go to another problem. Now, this problem is the opposite problem as before. In the previous problem, we convert from polar coordinates to Cartesian coordinates. Converting from polar coordinate to Cartesian coordinate are easy. Now we are going to convert from Cartesian coordinates to polar coordinates. So we are going to the point 2, 2. The point 2, 2, 2, comma 2. So it's good that you write the point 2, comma 2, and you write the x and the y. You don't be confused with the r and the theta. So the r is this distance from the center. What is this distance from the center? This r squared is 2 squared plus 2 squared according to Pythagoras. So 2 squared is 4, 4 plus 4 is 8, so the r is square root of 8. No problem, this is the r. Or if you prefer, a square root of 4 by 2, or if you prefer, 2 times the square root of 2. Okay, because the square root of 4 is 2. Okay, this is the r. And what is the theta? The theta is here. The theta is on the first quadrant. Oh, what is the theta? What is the angle? The angle that makes this 2 and 2 is 45 degrees. So it's pi divided by 4. So the point in Cartesian coordinate is the 2, 2. And the point in polar coordinates is the point 2 square root of 2, comma, pi divided by 4. To obtain automatically this pi divided by 2, you write tangent of theta equal opposite divided by adjacent is 1. So theta is pi divided by 4. And you know that it's in the first quadrant. And the problem is solved. So this point is the same point like the point minus 2 square root of 2, 5 pi divided by 4. So if you invert the sign here and you add pi to pi divided by 4, you have the same point. So what I have said is the point, let's go to write it here. What I have said is that the point r theta and the point minus r, comma, theta plus pi is the same point. In polar coordinates, the representation of the point is not like in Cartesian coordinate. In Cartesian coordinate, the representation is unique. In polar coordinates, the representation is not unique. So I like to stay with my standard 4 to take the r positive and the theta positive, so I will not be confused. This is the standard 4. So the theta is counterclockwise, very important, counterclockwise. And the r is positive if you start moving to the right, to the x. So 2 comma pi divided by 2 is here. So the pi divided by 2 is counterclockwise. Okay, let's go to the next problem. Let's go to problem number 4 is convert the point in Cartesian coordinate 0 minus 6, x equals 0, y equals minus 6. What will be the instruction for r and theta for polar coordinates? For polar coordinate, I have the 6, I rotate the 6, 3 pi divided by 2, and I arrive to the point. So for sure that in polar coordinates, the r and the theta will be 6, 3 pi divided by 2. Now I can play with this number. If I, instead of 6, I write minus 6, I will add pi to 3 pi divided by 2. So the point 6 and 3 pi divided by 2 in polar coordinate is the same point as the point minus 6, 3 pi divided by 2 plus pi. 3 pi divided by 2 plus pi is 5 pi divided by 2. So it's the same point as the point minus 6, comma 5 pi divided by 2, the r and the theta. These problems I convert the rectangular equations to a polar equations. So it's a polar form. So and describe the curve. Well, the curve is the same curve in Cartesian coordinates that in polar coordinates, but it has a different representation. So we know that this is a circle of radius 3, center at the 0. In Cartesian coordinates, the equation x squared plus y squared equals 9 is an equation that say that this is a circle. Okay, so what is r of theta? This is the question. What is r of theta? So I see that for any theta that I plug in, the r is 3. For any theta, the r is 3. So the equation in polar coordinate is r equals 3. And this is the equation r of theta equals 3. If you prefer, because r squared is equal x squared plus y squared, you write here r squared, or r squared equals 9, so r of theta equals 3 is the polar equation of this rectangular equation. Let's go to the next problem. Now we are going to convert from rectangular equation the equation x equals 12. The equation x equals 12 is the equation 1, 2, 10, 11, 12 is the equation that is x equals 12 for all y. So it's this equation. This is the equation x equals 12 is a vertical line. So What is r, the distance from the center, as an angle theta? What is r as an angle theta? Oh, the r and the theta, I need to find the r of theta. What is the value of r as a function of theta? How I will know? Well, I know that the x is the r cosine of theta. And let's say that this is the point, this is the point 12 comma y for any y. This is the structure of this point, 12 comma y. So the r of theta is the x divided by cosine of theta. But the x is the 12, and cosine of theta is what I have. So I have that r of theta is 12 divided by cosine of theta, or in other words, r of theta is 12 secant theta. So the polar coordinates of a rectilinear line in Cartesian coordinates is 12 secant theta. So if x equal 12, r of theta equal 12 secant theta. If x equal minus 2, r of theta equal minus 2 secant theta. This is the equation for a vertical line in Cartesian coordinates. This is. Now we do problem 7 that say convert from polar coordinate for a polar equation into a rectangular equation, into a Cartesian equation. So it's the inverse problem that we were doing in the two previous problems. So we have r of theta equal 5 cosine of theta, and we want to know what it will be, this equation in Cartesian coordinates, rectangular form. The trick to do this problem is to multiply by r both sides of the equation. So we try to get rid of the r and of the theta, and we have to make to appear the x and the y. How we will do it? If we multiply the r by the r, we have 5r cosine of theta. Now the r by the r is the r squared, but the r squared is x squared plus y squared. And the 5 is the 5, but the r cosine of theta is the x. Now we have to do a pre-calculus skill. So we need to complete the square. So this is the equation that we have. 5 squared, minus 5x equal y squared. So I will write this equation like this: x squared minus 2 times 5 divided by 2 multiplied by x plus y squared. I want to perform to complete the square. So it's x squared minus 2 times 5 divided by 2x, and now I will add 5 divided by 2 squared, and I will add this term squared, and I will not change my equation, so I will subtract minus 5 divided by 2 squared plus y squared equals 0. Now I will reorder this equation. To reorder this equation means x squared minus 2 times 5 divided by 2 multiplied by x plus 5 divided by 2 squared plus y squared equal 5 divided by 2 squared, where I have passed this term to the right. And now what I have? This is I have complete the square because this is x minus 5 divided by 2 square. This is a square of the first, x squared, plus a square of the second, 5 divided by 2 squared, minus 2 times the first by the second. The first, the x, 2 times the x by the second. So I would write this equation like x minus 5 divided by 2 squared plus y squared equal 5 divided by 2 squared. And what is this equation? So I have a start with the equation r of theta equal 5 cosine of theta. So this equation represents in Cartesian coordinate a what? A circle of radius 5 divided by 2, center at the point 5 divided by 2, 2, 3, this is the point, the center, the y 0, and the radius is 5 divided by 2, 4, 5, so this is the point 5 divided by 2, the center is at the point 5 divided by 2, comma 0, so the y points, the center here, there is a 0. So this is the center of this of the circle, and the circle have a radius 5 divided by 2. So if this is 2, this is 1. So it will do like this. 5 divided by 2 multiplied by 2 is 5, so the circle would be something like this. So this is r of theta equal 5 cosine of theta. Wow! This is r of theta. This is the r, and this is the theta. This is the r, and this is the theta. And r, the representation of the polar equation 5 cosine of theta. Let me see, it was 5 cosine of theta, yes. 5 cosine of theta is the circle with radius 5 divided by 2, center at the point 5 divided by 2, 0. Okay, let's go to the next problem. Minus 30, Okay, this problem say find the points. The points means the r and the theta that have horizontal tangents. So the curve, the polar curve is r equal 1 minus sine of theta. If you represent this point, this is the curve r equal 1 minus sine of theta. It has 3 horizontal slopes, 3, 1, 2, and 3. And we have to find this r and this theta. This r and this theta. And we have to find this r and the theta. I know what is the theta, is 3 pi divided by 2. Okay, let's go to do it. So when you will find horizontal tangents are found when the derivative of y respect to the x is 0, when the derivative of y respect to the theta divided by the derivative of x respect to the theta is found when the numerator is 0. When the numerator is 0, there is no change in y when theta change. So I'm looking for a condition where the derivative of y respect to the theta is equal 0, so means horizontal tangent. Okay, let's go to find y. So y of theta is r sine of theta. Okay, but r of theta is 1 minus sine of theta. 1 minus sine of theta multiplied by sine of theta. So this is y that depend on theta. You see, depend only on theta. So y of theta is equal sine of theta minus sine squared of theta. And what is the derivative of y respect to the theta? The derivative of y respect to the theta is cosine of theta minus 2 times sine of theta cosine of theta. And I want this to be 0. So I want cosine of theta that multiply 1 minus 2 times sine of theta to be 0. So when this is 0, this product is 0, when cosine of theta is 0. Or theta equal 0 when theta equal pi divided by 2. When theta equal pi divided by 2, this is 0. Let me see the picture. When theta equal pi divided by 2, wow, what is the r? What is the r at theta equal pi divided by 2? R of theta is 1 minus sine of theta. 1 minus sine of theta. So when theta equal pi divided by 2, r is 0. Oh, so I'm here at this point. Let me erase this. So when theta equal pi divided by 2, I'm at r equals 0 here. So this is a point of horizontal tangent. No, this is not a point of horizontal tangent. Probably the derivative of x respect to the theta is 0 also at this point. So don't pay attention to this because I'm looking for these points, these 3 points. This point, the r and the theta, the r and the theta, the r and the theta. So I'm looking for the r and the theta of each point. So don't pay attention to this because this is r equals 0. So probably the derivative of x respect to the theta is 0. And so this point do not consider as an horizontal tangent. So the part B will say that this product is 0 when 1 minus 2 times sine of theta is 0. So what we are thinking is, So what we are thinking that this product is 0 when this is 0 or this is 0. So we are working the case when this is 0. When 1 minus 2 sine of theta is 0, it means that 1 is 2 times sine of theta. It means that sine of theta is 1/2, positive 1/2, and sine of theta is positive 1/2 when theta equal pi divided by 6, 30 degrees, or theta equal pi minus pi divided by 6. Yeah, these 2 points, when theta equal pi divided by 6, sine of theta is 1/2, and when theta is here, so it's pi minus pi divided by 6 is also 1/2. So the 2 cases that I have to consider is theta equal pi divided by 6 and theta equal pi minus pi divided by 6. But pi can be written like 6 pi divided by 6. So this is 5 pi divided by 6. So this is the 2 cases. So what is the r? At this point we have horizontal tangent. So what is the r? R of theta is where is r of theta? R of theta is 1 minus sine of theta. 1 minus sine of theta. So if theta equal pi divided by 6, r of pi divided by 6 is 1 minus sine of pi divided by 6 equal 1 minus 1 half equal 1 half. So the point is r is 1 half. Theta equal pi divided by 6. So this is the r and this is the theta. So at this point I have an horizontal tangent. So if I go to the picture, I will find r is 1 half and pi divided by 6. So at this point I have a horizontal tangent, and this point have the r is 1 half, and the theta here is pi divided by 6. Now the next point is this one. At this point, the r is 5 pi divided by 6. So if theta equal 5 pi divided by 6, the r of 5 pi divided by 6 is also 1 minus sine of 5 pi divided by 6, which is 1 half. 1 minus 1 half is 1 half, and I have the other point. The other point is r is 1 half, and theta is 5 pi divided by 6. Now I need another point. I need this point. This one. Let me see from where I will find the other one. This is the equation. Cosine of theta is 0 when theta equal pi divided by 2, or theta equal 3 pi divided by 2. Okay, so now we consider this case. Theta equals 3 pi divided by 2. So if theta equals 3 pi divided by 2, r of 3 pi divided by 2 is 1 minus sine of 3 pi divided by 2. And sine of 3 pi divided by 2 is minus 1. So 1 minus minus 1 is 2. So the point is the point 2, 3 pi divided by 2. So these are the 3 points that have horizontal tangents. And at the point 0, r equals 0, theta equal pi divided by 2 or whatever, this point is not a point of tangent, of horizontal tangent, because it's true that at this point the derivative of y respect to the theta is 0, but it should be true also that the derivative of x respect to the theta is also 0, so it's not a point that you have to consider. As a result, these are the 3 points that have horizontal tangent. This one, and where is the other point? And this one. And the problem is done. This problem say find, this is also a cardioid. You can represent this cardioid. I think it will go like this. It will go something like this. Okay, this is the cardioid. The theta is from the center to the point. This is the theta. This angle is theta. So when you have the r, this is the r, and this is the theta. So r of theta is this function in polar coordinates 2, 1 minus cosine of theta. And when do we have vertical, they say vertical asymptote here. Here I see one vertical, here I see another one, here I see another one. So I see 3 vertical asymptotes, and well, they are not vertical asymptotes, they are vertical tangents, you know, they are vertical tangents. These are the 3. Let's go to find. So the derivative of y respect to the x is the derivative of y respect to the theta divided by the derivative of x respect to the theta. We can find vertical asymptote when the derivative of x respect to the theta is 0. When the theta change and the x doesn't change, we have vertical asymptote. So let's go to find what is the derivative of x respect to the theta. So the x of theta is r cosine of theta. But I know what is the x. The x is 2 times 1 minus cosine of theta multiplied by r cosine of theta. So this is the x of theta. So let's go to write the x of theta equal 2 times that multiply cosine of theta minus cosine square of theta. And the derivative of x respect to the theta equal 2 times that multiply the derivative of cosine of theta minus sine of theta minus 2 times cosine of theta multiplied by minus sine of theta, so this will be positive. So this is the derivative of x respect to the theta. So I want this to be 0, equal 0, and I want to find the theta. So 2 times, so I will write this like this. Sine of theta that multiply 1 minus 2 times cosine of theta. This should be equal 0. The 2 doesn't matter because 2 by something is the same thing. So sine of theta is here, and minus 2 is the inverse, that is the same thing. So this is equal 0 when sine of theta equals 0, or when 1 minus 2 times cosine of theta equals 0. When sine of theta is 0, sine of theta is 0 when theta is 0. When theta is 0 or when theta is pi, sine of theta is 0. And when 1 minus 2 times cosine of theta is 0 is when 1 is 2 times cosine of theta, or when cosine of theta is 1/2, or when theta is pi divided by 3. Pi divided by 3, or cosine 1/2 positive is on the 4 quadrants. So this is pi divided by 3, which is 60. This is the cosine that is 1/2 for this angle, and this is the other angle. So this is also 2 pi minus pi divided by 3. This is the other angle. 2 pi minus pi divided by 3 is this angle. What is this angle? Is 6 pi divided by 3, no? If I multiply by 3, 6 pi minus pi divided by 3, which is 5 pi divided by 3. So the two angles is 5 pi divided by 3. So I have this angle and these two angles. So it appears to be 4 vertical tangents, but there are only 3 vertical tangents. And what is happening is that at theta equals 0, it's true that the derivative of x respect to the theta is 0, but I suppose that the derivative of y respect to the theta is also 0, so this is undetermined. It's not defined. It's 0 divided by 0. So we choose theta equal, let's go to find the points. So from theta equal pi, because r of theta is 2 times 1 minus cosine 1 minus cosine of theta. For theta equal pi, r of pi will be 2 times 1 minus cosine of pi. Cosine of pi is minus 1, with this minus is 1, so it's 2 multiplied by 2 is 4. So the first point is 4 comma pi. The other point is when theta equal pi divided by 3. When theta equal pi divided by 3, because r of theta is 2 times 1 minus cosine of pi divided by 3, it will be 2 times 1 minus cosine of pi divided by 3. And remember that cosine of pi divided by 3 is 1/2. So the point will be, cosine here is pi divided by 3. So the point when theta equal pi divided by 3, the r at the theta pi divided by 3 is cosine of pi divided by 3 is 1/2. 1 minus 1/2 is 1/2. 1/2 multiplied by 2 is 1. So it's 1. Is 1. So the point will be the point 1 r comma theta pi divided by 3. So this is the point. The other point that I found that have vertical whatever you want to call tangent, 4 comma pi is the other point, and there is another theta here, this theta. When theta equals 5 pi divided by 3, r of 5 pi divided by 3 will be 2 times 1 minus cosine of 5 pi divided by 3. But cosine of 5 pi divided by 3 is 1/2, 1 minus 1/2, so this is 1. It's 2 times 1 minus 1/2. 1 minus 1/2 is 1/2. 1/2 divided by 2, this is 1. So the point is the point r 1 comma 5 pi divided by 3. As a conclusion, we found the 3 points that have tangents, vertical tangents. There are 4 comma pi, there are 1 comma pi divided by 3, and there are 1 comma 5 pi divided by 3. Now, where are these points? These points are, the r is 4, so this is the x, this is the y. The r is 4, 1, 2, 3, and 4. So you rotate the r, the angle pi, and you are here. -1, -2, -3, and -4. So this is 1 point, and this point have a vertical tangent. So the curve have a vertical tangent here, so it's doing like this. The curve is doing like this. Okay. The other point is the point 1 pi divided by 3. So you take the 1, you take this 1, the 1, and you rotate pi divided by 3. Pi divided by 3 is 60. So it will produce a point that have the magnitude 1, so it's a circle of radius 1, and this angle is 60 degrees, pi divided by 3. So this point is a point of a vertical tangent. So the point will do like this. Okay, it's like this. This point will do. Okay, let me put it in yellow. So at this point, they have vertical tangent. And the other point is the 1 5 pi divided by 3. 5 pi divided by 3 is when you go 5 pi divided by 3, so it is here. This is 1, this is the point 1, comma 5 pi divided by 3. Okay, these are the three vertical tangents of this problem. Let's go to the next problem. Okay, to do this problem, we have the intersection of two graphs. You can represent the two graphs in the web page that I show you how to represent, and probably is two cardioids. One is like this, and well, these are the two cardioids, so there is a point of intersection because they have the same size, and there is a point of intersection. Okay, these are the 2 points. These are the point of intersection, this one and this one. And they have another point of intersection here. They have, well, 3 points of intersection, no? Yes, this is a point of intersection when they have the same R, no. This point, the center, is not a point of intersection because they don't have the same R and the same theta. The R here is 0. The R in the other one, let me erase this thing. Let me erase here. The R here is 0. The R here is 0. But the theta is not the same. So I need the point of intersection is when the R and the theta are the same. So let's go to do it. Let's go to do it. So I have the R of theta equal 1, let me see, 1 plus cosine of theta, plus cosine of theta, and the other R of theta is 1 minus cosine of theta. So 1 minus cosine of theta is this one, and 1 plus cosine of theta is this one. And what I want to see, if I put it together, the two graphs, at what theta they will have the same value, the same R and the same theta. So when R equal R, if I want to put R2 and R1. When R1 is equal R2, is because 1 plus cosine of theta equal 1 minus cosine of theta. So this means that 2 cosine of theta is equal 0, or cosine of theta equals 0, or theta equals 0 when theta equals pi divided by 2, or 3 pi divided by 2. So where are the points of intersection? Well, the R of pi divided by 2 is 1 plus cosine of pi divided by 2. So it's 1. R1 or R2 is the same thing. It will give you 1. So the point will be the 1 comma pi divided by 2. So the R and the theta. 1 comma pi divided by 2. When theta equals 3 pi divided by 2, R of 3 pi divided by 2 is 1 plus cosine of 3 pi divided by 2, which is 1. Because cosine of 3 pi divided by 2 is 0, so the point is the point 1 comma 3 pi divided by 2. So these are the 2 points of intersection, and the point R equals 0 is not a point of intersection, because when R equals 0, you cannot make 1 plus cosine of theta equal 1 minus cosine of theta. You cannot equal this equation because there are two different theta are here at the 0. Okay, this is the problem. This is what we have solved. Let me see if I have solved it correctly. However, the graph indicates there is a third point on the origin 0, 0. However, this gives you 2 points of intersection. However, the graph indicates that there is a third point. The origin are 0, 0. This is not a point of intersection because this is the R0 and this is the theta. So this theta occur when theta equals 0 here. But this theta occur when theta equals pi. So it's not a point of intersection. Okay, this is the lesson. I hope you can enjoy this lesson.